So these was the default arguments. So let's understand by recursion. What is recursion? We have to create a one new recursion file .py. So when a function calls itself recursion, it means like it's a technique where a function calls itself to solve smaller instance of a problem. It is commonly used in algorithms like Factorial or Fibonacci series. So let's understand by getting the example. So def, I want to make one factorial function, and as a default we will use n. So if n is equal to 0, or n is equal to 1, so I want to return 1, otherwise return n factorial n minus 1. And now I want to print our factorial. So let's say I want to add factorial of 5. So save this and run this code. As you can see, we have the factorial of 5, which is 120. So we have the output of 120. So let's understand Fibonacci series using the recursion. So let's create a Fibonacci n, and I want to add if n is less than is equal to 0. So return invalid input. Else, so let's say elif, we can add one more here. So elif n is equal to 1, then return again 0. Elif n is equal to 2, can add return 1, or return Fibonacci n minus 1 plus Fibonacci, let's say n minus 2. And now we want to print Fibonacci of 6. Save this file and I comment out this. Save this file and run this file. We will get the phi output. Yeah, we have the phi output here. So this was the Fibonacci series using recursion. This Fibonacci series follows this pattern like 0, 1, 1, 2, 3, 5, 8, where each number is the same sum of the previous two. So let's start with a base case in recursion. And why it is important. Base case is like stopping condition that prevents infinite recursion. Without a base case, the function will keep calling itself forever and leading to the stack overflow error. So for that, we don't want to use incorrect example for that. So let's start with def infinite. So print, this will give us, this will go on forever. Infinite. So we will get the no base case. So if you run this code, we will get the no base case here, and